Hi, this is Aparna. In this big data ICP chain, we are going to create a model which is based on deep Q learning, and we have to train a model for cardboard game. So this cardboard game environment, we can take it from get big input basically from the open air gym from library. So this is the basically cardboard game. So this is the library from where we have to import the environment. This is nothing but the card, and there is a pole. It is attached on the frictionless surface. We have to move the card so that the pole should not fall. So maximum you hold it without falling the pole, you'll get a maximum score. So this is the basic thing about the ICP. And coming to the work I have done, these are the required libraries which I have imported. You can import it for this model. And after importing this library, these are like we can create an environment by Jim MC and by giving the name of the game here cardboard version 1. We can visualize, we can see it. So basically I'll showing it. And next, these are the accents, and we can talk about much more in detail action and the environment details. Basically we have a 2x in we can see like action it is what. So either we can take it to the right in the card pole or to the left in the card pole. And we have a 4 observations space, so in that case, or we can say the 4 states we have so far. It means like that each time state we can have 4 different observation, and the first one is like the position of the card and its velocity, the angle of the pole at the tip and the velocity of the pole at the tip. So all these 4 factors define whether how our the next current our next state would be depending upon our action. So these are the hyperparameters which I have defined. Here observation age of 4, we have taken maximum iterations 100. It means each game you will have 200 step. It means we have won the game, or this is the maximum point. So the learning rate of the model will be of we have given we are playing 200 times on the card pole, and it will train the model, and for each episode there will be 100 iterations depending whether we are that it game is done or not. So again we are with the random, we have given the random accent indicates 0.99, and we have initialized the random mix. We have defined some class functions. So first for the memory, we have defined the replay buffer. So that is the buffer, and we have taken the DQ as of our data structure, and which we have given from the collection library. we can pass the model and observation, get the Q value as output, and here we are training the model. We are passing the model observations and tag it to the model, and it will fit the model, or basically it will train the model based on the input which we have given. This is for the predictions. So this function will predict the model, will pass the model and the observation. So in the model we have a sequential. Model we have the sequential. I have the layers of dense layers over here for compiling the model. For the loss function I have given the mean square error. Optimizer I'm used as the Adam, and have added two dense layers of 24 neurons, and the input size will be the observation. We have defined the object observation dimension age of 4. So this is the states number of, as we have already discussed, like a 4 different states for each position, like for each time for the game, so that it will be the input, it will be the input, output be like true, output will be would be true, like whether you have, we have to go right or left, so we have only 2x, which we have defined for the model. Action will update the model based on uh, our observation. Main logic, I have given the brief description here of the code. So we are storing here of the last 50 game played, what's the minimum score of the 50th last 50 game played. So we are getting like the score, like we have 200 episodes, and for each episode we have a 200 iterations, and we are getting a score more than 195, and iterations is more than 195. It means we can conclude that the model is converged, our model has been trained now. So we will come out of the loop, and if not, it will go ahead and it will train the model. Here we are, we will train the model. Here we are, the random action by 0.99. Like we have already defined the capital letters into the hyperparameter section. Here we are taking the observation and we are resetting the observation for each game. And this is the iteration, like for each game we are doing the 200 iterations from 0 to 199, creating a random state, or you can say the random number, comparing the random accent probability, it is less than the, we will get the Q value from the model. And create the mean, and we will print the episode iteration. And what is the residual action probability for it, and if the game is over and iteration is 199, and we can, like the maximum iteration we can have at 199, because index from 0 to 199 the total iteration is 200. So if iteration is not equal to 199, we are giving a reward as a -5. If iteration is equal to 199, we are giving reward as 5. Here are my epochs. I have run So thank you.